Yes, hello students. Is it audible clearly? Yes, please tell me, is it audible?
Ma'am.
Okay, thank you. So sorry for the inconvenience, little network issues. Okay, so we were discussing the first question, that is, with rise in temperature, the Young's modulus of elasticity decreases, increases, changes, remains unchanged. Yes, the answer is, that is, it decreases. Okay, so it is inversely proportional. It is inversely proportional, right? So note down, that is, here the option A is the right answer. They are inversely proportional. So as they are saying, it increases the temperature, there will be the decrease in the modulus of rigidity, elasticity, Young's modulus of elasticity. So here that is option A. So going for the next question here, the Young's modulus of a perfectly rigid body is. So what is the value of the Young's modulus of a perfectly rigid body? Yes. See here, for the perfectly rigid body, again, so these are the ಇದನ್ನ ನೀವು MCQs ಅಂತ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು in your exam also, that is bold paper. ಆಯ್ತಾ? So yes, very good. That is option C is the right answer. The Young's modulus of a perfectly rigid body is infinity. Going for the next question, students. So it is a numerical question. You can see there, that is, a wire is of length 1 meter and its area of cross section is 1 centimeter square. Okay, so here a wire length is given. A wire length is given as 1 meter and its radius, not radius, that is area of cross section, is given as 1 centimeter square. Then next, the Young's modulus of the material of the wire is 10 to the power of 11. Okay, so please don't confuse there. It is 10 to the power of 11 Newton per meter square. Two forces each equal. F are applied. So the force applied on that is F, they are applied on its two ends in the opposite directions. If the change in the length is 1 millimeter, then the value of F is, yes. So let us see how to calculate that. The length is there, area of cross section is given. Then next it is given as the Young's modulus of the wire, right? So see here, let us calculate. What you need to calculate? The value of the force applied. ಎಷ್ಟು force apply ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅನ್ನೋದನ್ನ ನಾವಿಲ್ಲಿ calculate ಮಾಡಬೇಕಾಗಿದೆ students. For that, length is given, area of cross section is given, then Young's modulus is given as 10 to the power of 11 Newton per meter square. Two forces each of equal to F are applied on its two ends in the opposite direction. So in the opposite direction, in the sense, if one is in the downward direction, the other force is in the upward direction. So the two forces are in the opposite directions. Here what we need to do, we need to calculate the change in length is 1 millimeter, then the value of the force, Okay, so let us see how to do that one. As we know that Young's modulus is equal to, that is, longitudinal stress upon longitudinal strain. So longitudinal strain is given by, I'll take it as delta L, change in length by original length. So the formula can be written as, that is, F into L upon delta L into A. So this is Y is equal to, but we require to calculate the force. So to calculate the force, what we can do, it is Y into A Y into A, and this is delta L divided by the original length, capital L. Okay, so substitute madi, you will get the value of force. So very simple question. Substitute all the values here, students. That is, F is equal to, it is 10 into 10 to the power of 11 into 10 to the power of minus 4 into 10 to the power of minus 3, this whole divided by 1. So very simple simplification it is. So 10 to the power of 1 plus 10 to the power of 11 will be 10 raised to 12. 10 raised to 12, this is 7. So 10 raised to 4 baratte, right? So we have options 0.5 into 10 raised to 4, 10 raised to 4, 2 into 10 raised to 4 Newton. None of these. Yes, check which answer you will get. If any doubt is there in the simplification, please ask. This is to the power 1, 11 minus 4 minus 3. This is only 1. Actually, we will get 10 to the power of 5c. So here it should be 10 to the power of 5, not 10 to the power of 4. Okay. So answer will be 10 to the power of 5. Maybe typing mistake. Hope so this is clear to you. Here we have calculated the value of the force acting on the body. Okay. Going for the next question. See, the next question is a steel wire of area of cross section is 3 into 10 raised to minus 6 meters square can withstand a maximum strain of 10 raised to minus 3, and the Young's modulus of the steel is given as 2 into 10 raised to 11 Newton per meter square. The maximum mass the wire can hold is. So here you need to calculate the mass. Here they have given a steel wire of cross section. So the cross section, area kottidare. Area is given for the steel wire. Then after that, Young's modulus value is given, maximum strain value is given, right? So what you need to calculate here, you need to calculate the value of the mass. So ಎಷ್ಟು mass ಅನ್ನ ಆ wire hold ಮಾಡಬಹುದು. That mass value you have to calculate. So see how to do this one. Yes. How to do? So already I told you the formula. So in the formula, if you take force is equal to mass into acceleration, then the mass term will come. Can you try this? Yes, option C. Remaining students. I told you know already formula. Previous formula in use madidre, that only you can just modify little. Try ಮಾಡ್ತೀರಾ ಹೇಳ್ಬೇಕಾ? So what we can do, that is the maximum stress is equal to. So here we have, that is Young's modulus is equal to stress upon strain, right? So we just need to calculate the stress. So idanna now maximum stress anta tagolana, idanna maximum strain anta tagolana. Hagadre, so this will be maximum stress is equal to Young's modulus into the maximum strain, right? So y is equal to, as we know that stress is equal to, what is the formula? Force by area. So force is equal to mass into acceleration upon area. You write it as it is. Then here Young's modulus value is given. What is the value of the Young's modulus? That is 2 into 10 to the power of 11 into strain value. So strain value, what it is given? The maximum strain is given as 10 to the power of minus 3. So we just need to calculate the mass here. So mass and alle ittu bere ella terms and transfer ಮಾಡ್ಕೊಳ್ಳಿ students ಇಲ್ಲಿ. So here it becomes 2 into 10 raised to 11 minus 3. So 11 minus 3 will be, that is 8. 10 to the power of 8. Then next into area. So into area is how much? That is 3 into 10 raised to minus 6 upon acceleration due to gravity is 10. Do the simplification, you will get the answer. 60 kg. Option B. B. Option B ಬರುತ್ತೆ, C ಬರುತ್ತಾ? 60, no 6. Option B is right. So if you multiply here, 2 3s are 6, 10 raised to 8, 10 raised to minus 6, 10 raised to plus 1. 8 minus 6 will be, that is 2. Then if it goes to the numerator, this is 10. So it is 60. Yes, option B is the right answer. Go for question number 5, students. A cable that can support a load of, so load anta andre ನೀವು ಅದನ್ನ force ಅಂತ consider ಮಾಡಬಹುದು. The load of 800 Newton is cut into 2 equal parts. So here whatever the load is there, this load can cut into 2 equal parts. Okay, the maximum load that can be supported by either parts. So here a cable that can support a load of 800 Newton, this is cut into 2 equal parts. The maximum load ಅಂದ್ರೆ ಇದೇನಿದೆ ಇದನ್ನ equal part ಮಾಡಿದಾಗ ಈ ಕಡೆ ಮತ್ತೆ ಈ ಕಡೆ how much or maximum load ಎಷ್ಟು ಅದನ್ನ ಸಪೋರ್ಟ್ ಮಾಡತ್ತೆ. ಸೊ half of part ಎಷ್ಟು ಸಪೋರ್ಟ್ ಮಾಡತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಅಗೇನ್ ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಫೋರ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಓನ್ಲಿ. ಸೊ ಇಲ್ಲೂ ಕೂಡ ನೀವು ಇಲ್ಲಿ ಫೋರ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು. ಓಕೆ, yes. What is the answer? A, B, C, D. So here the values they have given is, that is a cable can support a load of 800 Newton. So this is supporting 800 Newton and this is cut into 2 equal parts. The maximum load that can be supported by either part is, so here the maximum load it can support is, that is 800 Newton only. ಯಾಕೆ ಹೇಳಿ? Option C. ಯಾಕಂತ ಅಂದ್ರೆ ಹಿಯರ್ ವಾಟ್ ಎವರ್ ದ ಲೆಂತ್ ಅಂದ್ರೆ ಅದೇನ್ ಲೆಂತ್ ಇದೆ, ಇಫ್ ದ ಲೆಂತ್ ಚೇಂಜಸ್ ಅದ್ರದ್ದೇನ್ ಸಪೋರ್ಟ್ ಮಾಡತ್ತೆ ದಟ್ ವಿಲ್ ನಾಟ್ ಚೇಂಜ್ ಹಿಯರ್. ಓಕೆ, ಸೊ ಅದ್ ಎಷ್ಟು ವೇಟ್ ಅನ್ನ ಸಪೋರ್ಟ್ ಮಾಡತ್ತೆ ಅದು ಚೇಂಜ್ ಆಗಲ್ಲ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಇಟ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಆನ್ ದ ಲೆಂತ್ ಹಿಯರ್. ಸೊ ಹಿಯರ್ ಯು ವಿಲ್ ಸ್ಟಡಿ ಅಬೌಟ್ ದ ಬ್ರೇಕಿಂಗ್ ಸ್ಟ್ರೆಸ್ ಅಂತ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ. ಸೊ ಬ್ರೇಕಿಂಗ್ ಸ್ಟ್ರೆಸ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದಿ length of the cable. So it does not depend on the length of the cable. Okay, so therefore same weight anne support ಮಾಡುತ್ತೆ, that is 800 newton. 800 newton only it will support. The next question, students, the breaking stress for steel is 8 into 10 to the power of 5. So next is, that is the stress value is given as 8 into 10 to 5 newton per meter square, and its density is 8 into 10 to 2 kg per meter cube. The maximum length of a steel wire which can remain suspended without breaking is. Yes, the maximum stress. The maximum stress is 8 into 10 to the power of 5, and the density is given as 8 into 10 to 2. The maximum length of the steel wire which can remain suspended without breaking is. If you see the options, it is given as 1000 centimeter, 100 centimeter, 100 meter, 1000 meter. So if you do little mistake also, you will get the wrong answer, right? So you need to do it properly here. Here the breaking stress is given as, that is 8 into 10 to the power of 5. W is equal to mg, weight is equal to, weight of the wire is expressed as mg. So to calculate the mass, okay, so what we need to calculate here, the maximum length of the wire. So fast you people are getting option. Option D. Option D or option C? Hema, Fatima. Yes, remaining students. Option C. Yes. Solve ಮಾಡಬೇಕಾ? Otherwise solution is clear to everyone. So here, that is stress is equal to force upon area, right? So force is equal to, we have mass into acceleration upon A. Then next, here density concept they have given. Therefore, density is equal to, that is mass per unit volume. So therefore, mass is equal to, it will be what? That is mass is equal to density into volume, right? So therefore, idana density into volume into G upon area anta barkoli. So volume can be written as, that is area into length into G upon A. So area will get cancelled. Therefore, we will have, that is stress is equal to. So stress is equal to, the formula will be what? That is density into length into acceleration due to gravity. So we require the length. Therefore, length is equal to, what we can do? Stress is how much? It is 8 into 10 raised to 5. Then the remaining value is in the denominator, and the density value is also same. It is 8 into, but 10 raised to 2. Then next here, acceleration due to gravity is, take it as 10. Yes, so 8 will get cancelled, 10 raised to 5, 10 raised to 3, it will be 10 raised to 2. So 10 raised to 2 anta andre estagutte, 10 raised to 2 is nothing but 100. So answer is option C. Yes, any doubt is there? Any doubt, students? Otherwise, I'll go for the next question. Why all are silent today? See the next question, 7th question. The cross-sectional area of a steel wire is 2 centimeters square. So here they have given the cross-sectional area is given. Here the force required to double the length of the wire. In the bracket, they have given the value of the Young's modulus, and that is as 2 into 10 to the power of 11. Okay, so the cross-sectional area of the steel wire is 2 centimeters square. The force required to double the length of the wire is, that is length force you need to calculate here. Force and calculate ಮಾಡಬೇಕಾಗಿದೆ to double the length of the wire. Young's modulus is given as 2 into 10 to the power of 11. Then area of cross section is given by 2 centimeters square. The force required to double the length. So the force required to double the length we need to calculate. So first question in solve madidvi, that is third question. Same way you can try this. Young's modulus is equal to, it is stress upon strain. So stress is force by area. Strain, what they are saying, the cross-sectional area of length is given. So cross-sectional area is there. The force required to double the length. So see here, students. See, for example, if the initial length is 1, okay, then here the change in the length, as we know that strain is what? Strain is the ratio of change in length upon original length. It is change in length upon original length. So in the question, what they are saying, you are doubling the length of the wire. You are doubling the length of the wire. So when you are doubling the length of the wire, so here the initial length and when you, whatever the change is there, if you take the ratio of that, the strain value will be 1. So strain enagate 1 agate. Why? Because when you double the length and the initial length, when you take the ratio of that, it will be giving you answer 1. Okay, so therefore stress upon strain, strain answer is 1. So stress is equal to force divided by area. What we need to calculate? We need to calculate the force. So hagadre Young's value, Young's modulus value, it is 2 into 10 to the power of 11 into area value is 2 into 10 to the power of centimeter square. So therefore it will be 2 into 10 to the power of minus 4. So 2 into 2 will be 4. Then 11 minus 4. So 11 minus 4 will be 7. 4 into 10 raised to 7. So in the option 4 into 10 raised to 7, yes, it is there. Option C is the right answer. Yes, please ask if any doubt is there. Option C is the right answer. Please ask if any doubt is there. Otherwise, I'll go for the next question. Yes. Okay, then go for the next question. That is question number 8. When a certain weight is suspended from a long uniform wire, its length increases by 2 centimeter. Its length increases by 2 centimeter. If the same weight is suspended, from another wire of the same material and length, but having a diameter half of the first one, the increase in the length will be. So what is the value of the increase in the length? Yes, how to do this one? See, what they are asking in the question here, students. See, when a certain weight is suspended from a long uniform wire. So here you can imagine the wire. So some weight is suspended for that. Its length increases by. So whatever the original length is there, its length increases by 2 centimeter. If the same weight is suspended from the another wire, okay, for the same material and length, but having a diameter half of the first one. So if the value of the diameter of the first wire is d, the value of the diameter of the second wire is d by 2. The increase in the length will be 0.5 centimeter, 2 centimeter, 4 centimeter, 8 centimeter. Option C. Option C is what? 4 centimeter. Yes, answer is right. 4 centimeter. Oh, many students are giving answer. Very good. So if anybody requires, actually you can calculate without simplification. Means you can understand the answer without simplification also. Yari simplification bekide, just see that one. So Young's modulus is equal to stress by strain. Okay. So here the delta L value is given as 1 centimeter. Delta L1 value is given as 1 centimeter, and A1 will be, it is pi R1 square, and A2 value will be pi R2 square. Okay. So now F by area, that is force per unit, that is force by area upon delta L1 by L is equal to, because they are equal, that is Young's modulus of both the material is equal. So therefore we can take it equal here. F by A2, this is whole divided by delta of L2 by L, delta of L2 by L. So now next let us simplify this one. So as you can see that the force, the length value will get cancelled. Therefore, we will have, that is delta of L2 by delta of L1 is equal to, it is A1 divided by A2. Yarig artha aglila, please kelkoli. So area is nothing but what here, student, that is pi r square. So for first one it is pi r1 square, and for second one it is pi r2 square. Again, the pi values will get cancelled. Namak bekagirodu delta L2. So therefore, this is delta L1 is equal to, delta L1 is equal to, this is R1 square divided by R2. But the radius value is, as the diameter is decreasing, the radius will be also decreasing, right? Into, sorry, here only it will into come. Okay. So that is delta L1 into R1 square upon R divided by 2 whole square, right? So now we can substitute the value here. So delta L1 value is 1 into. So here the value is R will get cancelled. This is R1 will get cancelled. 2 square will be 4. So if it goes to the numerator, 1 into 4. Therefore, the answer is 4 centimeters. So many students have given the option as C. Option C is the right answer. Yes, completed. Okay. So I am going for the next question, students. See. First, tell me answer question number 10. Question number 10 ning answer madi, then we will do those two numericals. The dimensional formula for stress is same as that of force, pressure, torque, work. The dimension formula of stress is same as that of. Yes, fast, quick answer. Yes, what is the answer? This dimension formula of stress is same as that of what? Pressure. Because stress is also force by area. Pressure is also force divided by area. Therefore, the dimension wise both are equal. So, dimension formula of both will be equal. So, for 10th one, option B is the answer. Going for the question number 9, a string of 1 millimeter diameter. So, the diameter is given as 1 millimeter. Breaks if the tension in it exceeds 80 Newton. So the tension in it exceeds 80 Newton, it breaks. The maximum tension that can be given to a similar string of diameter 2 millimeter is. Yes. So when the diameter is 1 into 10 raised to minus 3, that is 1 millimeter, the force is 80 Newton. If the diameter is doubled, how much force or the tension you can give it to the string? Yes, very simple answer. Yes. How we will do this one? So the maximum stress is nothing but the breaking stress, right? So as it is, stress is equal to force by area. So force is 80. Area is given by pi r square, but the diameter value is given. So pi r square means here you can take it as pi r by 2 whole square. So as the diameter is 1, the radius value is also 1. Therefore, this becomes 80 divided by, that is pi by 4. 80 divided by pi by 4. This is equation 1. So this is, you can take it as stress 1. The next stress 2 can be calculated as F2 is equal to, here F value we don't know, and here what we can do, the diameter is, it is 2 millimeter. It is 2 millimeters. So therefore this becomes r square by r by 2. So r by 2 whole square is nothing but what? That is, yes. So equating equation 1 and 2, we will get the value of the F. So when I equate equation 1 and 2, it will be 80 divided by pi by 4. This is equal to F divided by pi by 4, and here it is 2 square is 4. So I can cancel this pi by 4 on both the sides. So this is 80 into 4. That is 380. So 320. Option C is the answer, right? Option C or option B? Yes, option C is the right answer. 320 Newton. So option B, C, that is 320 Newton. Option C is the right answer. Okay, going for the last question for today's class. See the question here, students. The ratio of diameter of the two wire of the same material is. So the ratio of the diameter of the two material of the same material, okay, of the same material is given as n is to 1 means n by 1. The length of the each wire is 4 meter. Here the length of both the wire is what? It is 4 meter. On applying the same load, the increase in the length of thin wire will be. So you are increasing on applying the same load, there is an increase in the length of the thin wire will be. So N1 is greater than N2 times, N times, 2N times, 2N plus 1 times. Yes. See how to do this. Here it should be n is greater than 1. Okay, so here don't confuse. This is the value of n is greater than 1. Okay, so see here, students, as we know that Young's modulus is equal to stress by strain. So directly I am writing this formula. Hope you will understand. So force by area, force is mg, and that change in length upon original length. So this is the original length. Upon area, I will take it as pi r1 square into delta L1. Okay, so this is equal to mgl upon pi r2 square into delta L2. Right? So now this is for first one, this is for the second one. We can just equate these two equations. So let us equate these two equations so that the same terms will get cancelled. So when the same terms will get cancelled, we will have that is R1 square into delta L1 is equal to that is R2 square into delta of L2. So therefore this becomes delta L2 divided by delta L1 is equal to, this is R1 upon R2, this whole square, R1 by R2 whole square. Okay. So in the question what they have given, the ratios it is given as what? N by 1. The ratios it is given as what? N by 1. So therefore here I'll take it as N divided by 1. This whole square, which is equal to, this is delta L2 upon delta of L1. Okay. So we require delta of L2. So delta of L2 is equal to, students, here it is n square into delta of L1, which means that it is n square times, it is n square times option A is the right answer. Yes. If any doubt is there, please ask here, students. Any doubt? This chapter is completed in college, mechanical properties of solids. No, then in the beginning only you should tell, no, when I started the questions. Other students, then without theory, how you will understand? Still in gravitation, okay. Okay, just revise this, means once the chapter is completed, because in some colleges they will complete, in some college the arrangement means arrange syllabus distribution irutte, different irutte, so we can't help. So see, ಯಾರಿಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ ಅವ್ರಿಗೆ ಸ್ವಲ್ಪ ಅರ್ಥ ಆಗುತ್ತೆ, ಯಾರಿಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿಲ್ಲ, ಆಫ್ಟರ್ ದ ಥಿಯರಿ ಕ್ಲಾಸ್ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದಟ್. Otherwise, in our Sankalp classes, you will get this lesson theory part kuda ನಾವು cover ಮಾಡಿದೀವಿ. You can go through the YouTube channel. Okay, so we will meet in the next class, students. Okay, so thank you. Bye bye.